Your response to climate change. Section 1. Explanation of the causes and consequences of climate change. The natural effect causes. Orbital changes and the Milankovitch theory explain the three cyclical changes in the Earth's orbit and tilt. These changes occur over hundreds of thousands of years. Earth's orbit changes every 100,000 years, the tilt changes every 41,000 years, and wobbling on the axis every 23,000 years. Edgar's 2018. Volcanic eruptions discharge carbon and sulfur dioxide, which blocks sunlight in the atmosphere. This results in a cooling effect, which usually occurs at a local level, but with greater eruptions, this can affect global temperatures. For example, in Mount Pinatubo in 1991, where global temperatures fell by on average 2 degrees, USGS 2015. The El Niño effect occurs every 3 to 10 years and occurs when the southwestern trade winds weaken, allowing warm waters to travel to South America. This causes more rainfall in South America and therefore less intense hurricanes in the Atlantic. Sometimes after this, La Niña occurs, which is the extreme of normal conditions, which means it's even drier in the Atacama Desert in South America and wetter in Australia. These are some of the worldwide natural effects that can affect global climate. Moving on to the anthropogenic causes of climate change. Anthropogenic is the human impact on the environment. For example, with burning fossil fuels, this is the most well-known example of releasing carbon dioxide into the atmosphere, which enhances the greenhouse gas effect, which warms the planet. Also, trees absorb carbon dioxide under the process of photosynthesis, and with deforestation, carbon stores are reduced, which means there is more CO2 in the atmosphere. The release of carbon from deforestation accounts for 15% of all global greenhouse gas emissions, Birkin Center for Climate Research 2015. Also, agriculture through cattle farming can release methane into the atmosphere, which acts as a large pollutant and is worse for the atmosphere compared to CO2. Comparing this statistic to other carbon dioxide emitters, a kilogram of beef is responsible for the equivalent of the amount of CO2 emitted by the average European car every 250 kilometers and burns enough energy to light a 100-watt bulb for nearly 20 days. DEFRA 2017. Now considering past climate change through measured and reconstructed methods. Different techniques to measure and reconstruct past climate change can be used, with some of these methods being more reliable and scientifically accepted than others. Some methods are seen as unreliable and tend to vary in accuracy the further back in time they try to predict past temperatures. Past climate change can be measured quite accurately by ice cores up to 800,000 years ago. This is done by analysing carbon dioxide levels found in air bubbles within the ice. British Atlantic Survey 2014. The British Antarctic Survey have compared ice core data with atmospheric data in the graph to the left, and the results they found had a strong positive correlation. This means that the data found from ice cores can be trusted and used to calculate past temperatures. The second graph to the right-hand side demonstrates how the Antarctic can be used as a proxy to measure change in local temperature for up to 800,000 years ago. The peaks in this graph represent interglacial periods, whilst the troughs represent glacial periods. Similarly, other methods can be used to help reconstruct past levels of climate change. For instance, pollen in fossils that are located on the seabed and have been dug up. NOAA 2019. This allows scientists to analyse the amount of pollen in the atmosphere at the time, which helps them to work out the conditions for plant growth, therefore indicating temperature. Ocean sediment cores and animal shells can also be used to measure climate, as their thickness is dependent on water temperature. Also, tree ring width depends on the climate and soil water levels at the time of growth, giving scientists a yearly growth rate, as trees put on a new ring every year. University of Oxford 2017. Glacial effects can also be measured with moraines. This can be done by observing the variation in the sizes of glaciers and looking at moraines to see where they were in the past and if they have been moved considerably. This can be shown in the Climatica 2014 graph on screen and the shifting of moraines down slope. Future climate change models and predictions. The IPCC are the main body that predict future projections of climate change by looking at the effects of greenhouse gases on global changes in average temperature. The IPCC then look how these predictions will affect other things, such as crop yields and other environmental factors. They have found that the further into the future they try to predict, the harder it becomes to get accurate predictions, but they have a medium to high confidence level that temperatures will rise by 1.5 degrees in the next century, IPCC 2015. This graph shows this effectively as it is the estimated anthropogenic warming to date and then in the future. These changes can be shown by the different colours in their level of confidency. Another method and organisation that predict future climate change is the EPA from the United States, which have their own climate predictions for the future. And this graph goes up to the year 2100. These predictions suggest the different routes that emissions could take in the future and how this will affect the climate. In this case, there is a highest emissions pathway at over 1300 parts per million of CO2, and the lowest stays similar to our current CO2 emissions at just over 400 parts per million. These predictions remain similar to the IPCC's as these organisations work together with their predictions and there are too many uncertainties to predict outside of this range. There have been little debate over these predictions as they are quite well renowned within the scientific community. With future predictions, it is hard to be accurate due to the many factors that can affect carbon dioxide emission levels. In general, the longer periods of time projections occur, for the more inaccurate they become. The main factors that are known with regards to carbon emissions are future climate deals, future energy sources, future transportation measures, and future fossil fuel supplies. We don't know the effect feedback mechanisms will have on the future climate, such as the effects of albedo. The effect of the albedo on climate was called statistically significant by Hall and becomes very hard to model and predict due to the high number of factors that will affect future albedo rates. Hall 2004. Likely changes and consequences of climate change in the future. Precipitation rates and locations are likely to change in the future as a result of climate change as weather patterns shift across the globe. From the synthesis report in 2014, in the graph, changes in average precipitation can be shown comparing the two graphs. Also, there will be an increase in abnormal weather patterns. Tropical storm intensity and quantity will increase, as well as the distribution of tropical storms. If waters are warmer in the Atlantic and Pacific, there are more chances and the likelihood of tropical storms increases as water has to reach 27 degrees to become the conditions for a hurricane to occur. This means that tropical storms could occur in higher latitudes. The Arctic could also become free of ice. In the September Arctic sea ice is apparently declining at a rate of 12.8% per decade according to NASA's recent studies in 2018. This is an alarming rate and soon the Arctic could become ice-free. Also, sea levels are rising and will rise in the future as a result of the Arctic ice and other ice caps melting. Projections are hard to be accurate for this as we are unknown in the future of how quickly the ice will melt and what effect the albedo will have on this. RisingSea.net have predicted projections for the future, with sea level change at a maximum reaching 450 millimeters higher than it currently is. Moving on to section 2, discussion of the debate surrounding the subject. The consensus for global warming and climate change isn't 100% amongst the scientific community. Cook found that there was a 97% consensus among scientists that humans are causing rapid global warming. This data collection was based on the analysis of just under 12,000 research projects and abstracts. Cook et al. 2016. Importantly, in Cook's data collection, he found that the greater the expertise in climate science, the higher the scientific consensus, as shown. This implies that the more people understand and know about this topic, means the more likely they are to agree with that climate change is induced by mankind. However, some scientists believe that climate change is not happening and they have evidence against the contrary. From the graph above, some people use the perspective of scientists that are not specialised in climate science, such as meteorologists and economic geologists. Cook describes individuals that follow this data as in science denial, Cook et al. 2016. For example, an economic report by Richard Toll claimed climate change would have a positive effect on the economy. The IPCC later corrected this claim and removed him from their report due to his failure to use correct data in his investigation. This graph is the hockey stick graph, which has been criticised by theorists such as McIntyre in 2004. He claimed that it was inevitable due to the results of statistical methods used. They also claimed that the temperatures over the 15th century were derived from one Bristol cone pine proxy record. They concluded that the hockey stick shape was not statistically significant. An independent assessment of man's hockey stick was conducted by the National Centre for Atmospheric Research, WAL, 2007. They reconstructed temperatures employing a variety of statistical techniques. Their results found slightly different temperatures in the early 15th century. However, they confirmed the principal results of the original hockey stick graph, which is shown, and that the warming over the last 600 years has increased at a rapid rate. Section 3. Actions that need to be taken and the benefits of these actions. Businesses can take actions such as involving two main causes: value protection and value creation. Value protection involves undertaking risk assessment, adapting existing processes and equipment, and increasing insurance cover. An example of this is using different fuels, which can be seen in Coventry University's ECB building and the biomass boiler as its main source of fuel. Also, value creation and opportunities can be used by businesses to meet the changes that climate change will have upon our environment. For example, creating and selling new technologies and making improvements to logistics and transport procedures. For example, this could be using electric or hydrogen cell-powered cars. Businesses need to be aware of climate change as it's a legal requirement and it could have negative financial risks in the future for their business. Next, individuals need to be aware of climate change, and it's important to deal with climate change as individuals consume lots of energy. Necessary action needs to be taken by individuals, especially in the UK, include loft insulation and double glazing, as this increases the energy efficiency in houses, which reduces the amount of heat loss from homes. This means that less fossil fuels need to be burnt and therefore less carbon dioxide produced. Not only does this benefit the individual, as they pay less for the heating bill, but it benefits the environment as well. Additionally, individuals can opt to change their diet to reduce the amount of meat they have in their diets. This can be done by becoming vegan, as meat is a large producer of carbon dioxide, as discussed in previous slides. Also, consumers can make ethical decisions about where they get their food from to reduce air miles. This reduces transportation costs and will reduce the amount of emissions produced. The government have already implemented legislation to help protect the environment against climate change. In 2008, the Climate Change Act was created, which created a set of targets for 2050, as well as outlined how the UK was going to start carbon budgeting and carbon accounting. Legislation.gov 2008. In the future, stricter targets could be set out to ensure targets are met and the impacts upon the residents of the UK reduced. Governments could use their resources to remove carbon dioxide from the atmosphere, for instance using different techniques such as afforestation or synthetic trees. These techniques help to remove carbon dioxide from the air, which would in turn help to reduce temperatures if schemes were implemented at a large enough scale. However, challenges with carbon dioxide removal techniques remain persistent with high costs and their feasibility and scaling issues. These methods would only remain effective if they were implemented across governments on an international scale. Section 4. Reflection on my own carbon footprint and development for the future. An estimate of my own carbon footprint. I calculated my carbon footprint using a carbon footprint calculator, as it provided an accurate breakdown of my footprint into separate categories. I made sure that the correct electricity output was used for this, and I broke it down into kilowatt hours and then calculated it by timesing the two together. As you can see on the left, my carbon footprint with house, flights, cars, bus and rail, and secondary items. Also, you can see the carbon footprint of mine compared to the UK and then compared to the world. Compared to the national and international average, my carbon footprint remains low due to the lack of high carbon dioxide emitting transport I use. For instance, I tend to walk and bike a lot, which means I don't need to drive as much. Also, I only took one flight during the course of the year. My methodology for electricity consumption was calculated by dividing the total amount of energy used in my house by the number of people living within it. Also, I used secondary consumption to look at my secondary purchases and how this might add to climate change and greenhouse gas emissions. Last year I bought around £500 worth of clothes and then calculated using fashion websites to gain an idea of the amount of air miles. I then times this by the cost of the air miles and then the greenhouse gas emissions produced from these air miles. Section 5, the reference list.